Well, a warm welcome to anyone joining. Thank you for being here. Get yourself ready with a notebook, grab a pencil or pen. Whatever you choose to write with is fine. This is math from the void. Math coming at you pretty much out of nowhere. And today we have a problem that is an SAT style problem for sure, involving circles yet again. But this time, we're not talking about the length of line segments that cut through a circle. No. This time, as indicated by my lovely diagram, we're looking at angles and arcs. We have the same mathematical objects. In this case, we have two secant lines, but I don't really feel the need to describe them in terms of secant lines. This is not a geometry class. Really, I want you to understand the inside-outside rule for arcs and angles. So if you'd like, if you're so bold, go ahead and give yourself a chance to try this problem for yourself. Pause the video. Take about maybe 1.5 minutes, maybe 2 minutes, even though that seems like a little longer than necessary. And if you need longer than that, I mean, hey, this is about improvement. So get yourself used to struggling through problems, even if it takes you a while. Then when you're ready, you can unpause the video, come back, and see how we did it here. All right, so just to be clear, we have this angle here is 20 degrees. This angle here is 50 degrees. P is that's just the circle center, so point P doesn't really involve itself with the angle. But I do want to be clear that this angle is not drawn at the center. So that's why I put the center point where it is. It's in the center. This angle, 50 degrees, is not a central angle. You would approach this problem very differently. It would be very easy to find x and y if this were, in fact, you wouldn't even need these secant segments if this were a central angle. There'd kind of be almost no work to do. So let's get started. I'm going to make a separate video, as I mentioned, about the inside-outside rule, because we have an inside-outside rule for line segments, and then we have an inside-outside rule for the arcs and angles created by these segments. What do I mean by inside-outside rule? Well, the inside rule is referring to the vertex of an angle which is inside the circle. It's almost as if that word inside is very telling. Yes, it is. That means we're talking about this angle here, and you'll notice that this one, because of vertical angles theorem, is also 50 degrees. Not really necessary for us, but it is true that it's 50 degrees. Now, the inside rule for angles and arcs says that the measure of the angle is equal to 1/2 the measure of, I guess I should just say, arc 1 plus arc 2. And if you look at the intersection, the vertex here, there's one arc that's created on this side of things. That would be y. There it is. And then we have an intersection along this side of things, which creates an arc called x. Now, x and y are not necessarily the same arc value, even though these two angles are. So this is the inside rule, okay? We have intersection on the inside of the circle, and this is the relationship between the angle at the intersection and the arcs created by the segments. Then we have this angle out here, and its vertex is outside of the circle. Drum roll, please, for the name of this rule. Yes, it is the outside rule. And it's very similar to the inside rule, but it's different in one very important way. For this, we're going to say that the measure of the angle is 1/2 still. Notice the similar equation, but instead it's going to be 1/2 what I call big minus small, and I'm referring to the arcs. Let's look at what I mean. From this point, from this vertex, the line segment carries through and cuts through once, and it cuts through again. Whereas on this line segment, the secant line, it cuts through once, cuts through again. You can see which one is the big angle. Almost looks like a diagram of like a human eye or something. If you're in bio, you might see something similar to that. And what's happening here is we have two arcs because these segments penetrate through the circle and then they hit the edge of the circle. theoretically this would continue going outwards. So the big arc is simply the bigger one when it's about to exit the circle, this one x, and the small arc is the first arc where the two segments penetrate through the circle. So this is going to be measure of the angle, which is 20 degrees, equals 1/2 x minus y. Okay, for the inside rule, let's plug in our values. We know that the measure of the angle is 50 degrees, and that's going to be equals to 1/2 arc plus arc, so x plus y. Here we have two equations with the same two missing variables. So pretty straightforward to solve this. That means that 100 is equal to x plus y. But on the other hand, 40 is equal to x minus y. So how do we solve this? Very SAT-like, right? We need to solve for x and y. We can just kind of stack them. 100 equals x plus y, and then on top of that, or rather below that, we'll have x minus y. So let's add these equations together to get a really nice result, because the y's are perfectly canceling each other, leaving us with a total of 2x equal to 140, and of course x equals 70. So the arc, the big arc, is 70 degrees. We can use any one of these two equations very simply. Let's use the top one. So 100 equals 70 plus whatever y is, and we can easily solve for that as well. By subtracting 70 on both sides, we get that y has to be equal to 30 degrees. We're not done, guys. You thought we were done? We're not done. Read the question. I'm doing this on purpose because the SAT will absolutely do this kind of a thing. We don't just want the value of x. We don't just want the value of y. We want the value of 3x minus 2y. So just got to be a little careful there. Plug in your 70. Plug in your 30. Was it 30? Am I tripping? No, it's 30. Minus 2 times 30, so we get 210 degrees minus 60 degrees for a total of 150 degrees. Very SAT-like for them to not just have you solve some variables, but then to do this sort of extra step and interact them somehow. Maybe you have to add them, maybe you have to multiply them, or in this case, you had to produce a linear combination, which just means multiplying them by some number and then adding or subtracting them together. Okay, pretty quick, good, clean family fun there. As I said, keep an eye out for this inside-outside rule video. It's going to be more of a geometry concept-focused video. But I think that's enough blab out of me, and I'll see you guys next time.